And begin. Welcome to Computer Science E-75. This is lecture 0, HTTP. My name is David Malin. I'll be your instructor this semester. And I'll start off perhaps with some bias by saying I actually think this course is a lot of fun. But in large part because it's very much project-driven, because the content we cover is very much new, in vogue, a lot of fun. And what I think is particularly compelling about building dynamic websites these days, and we'll tease apart exactly what we mean by that tonight, is that how increasingly, at least in the web context, is programming becoming less about having to implement everything from soup to nuts yourself and more about more about wiring things together, taking off-the-shelf parts, libraries that other people have developed, SDKs that other people have provided, and solving the problem that's actually of interest to you and implementing the project that you want to solve, but without having to implement every little widget or every little component yourself, which for a long time, at least for me, took a lot of the fun out of programming, since anything compelling would take me weeks and weeks and weeks to actually accomplish, and now it's been whittled down to days or weeks. And so it's an exciting time, I think. And so what we'll cover in this course is a range of material. What I thought we'd do is a whirlwind tour of the kind of content that we'll look at. I'm going to go in reverse order here and give you a quick sense of the trajectory for the course. And we'll actually dive in tonight to the fundamentals of what goes on between browser and server and exactly where in there we're going to be playing this semester. So tonight is about setting the mental model for how websites in general and dynamic websites specifically actually function. What actually happens when you go to foo.com, hit enter, between you and that server. Because in large part, getting a website up and running on the internet, whether it's for work or for own personal purposes, has a few aspects to it. None of which are very hard, but they generally need to be done in some sequence. And for Project Zero in this course, will you actually do all of those steps yourselves? And so we'll talk tonight about things like HTTP, tiny little bit about HTML and CSS, more about DNS and web hosting and virtual private servers and all of the sort of options that are available to you when you decide, I need to build something. And the next question is, how? Next week, we'll dive into PHP. So PHP is very much a popular language these days, kind of sits alongside other popular options like Ruby and Python. What's particularly nice, I think, personally about PHP is, frankly, the learning curve is incredibly low. And of those three languages in particular, I think, frankly, the documentation for PHP is hands down the best and the easiest to navigate. And so pedagogically, it's been a wonderful tool for us to choose as a course because most anyone with some prior programming experience, whether it's in Java or C++, C# or some higher level language, can pick up this particular language relatively quickly. That doesn't necessarily mean you'll pick it up quickly well, but we do have a whole semester in front of us. And in fact, I think PHP's downside, or Achilles heel perhaps, is just how much bad PHP code there is out there. If you've ever downloaded various open source projects, or maybe you haven't, because perhaps not knowing PHP yet, you simply don't choose these off-the-shelf products, but they're a scary mess, a lot of the options out there. Among some of the most popular tools, we, for instance, for a course I teach, use MediaWiki, which is the free software that drives Wikipedia. Looks great above the hood. When you actually open it up inside, it's scary what goes on underneath there. And it's been cobbled together over time, and it's not necessarily the best paradigm. So what we'll focus on in particular in this course is not just how to accomplish some task, but how to do it well, and hopefully how to build projects that you can actually return to in months and years and actually understand what you did and even pass them on to other people. So design choices will be a theme throughout the course is projects. We'll spend a couple of weeks on PHP itself. Not so much the boring syntax, here's a for loop, here's a while loop. We can wave our hands at a lot of those details pretty quickly, as we will next week, and really dive into some of the features. What does it mean that PHP supports sessions and does automatic cookie management for you? What does it mean to maintain state? What does it mean to implement the notion of logins and registrations? Sort of core components that you find in many websites these days. How do you actually do that with this particular language? And where does it actually sit between user and internet and server and operating system and disk? Exactly what pieces get involved. And in fact, fast forwarding momentarily, we'll talk in particular toward the end of the semester about not only how do you use PHP and these related technologies to run a site, but to run a big site. If you start getting not tens or hundreds of users or hits, but thousands or tens of thousands, you start having to make a priori some interesting design decisions when it comes to your database schemas, when it comes to the kind of code that you're writing, how and where you host your libraries. A lot of interesting issues arise that the most popular websites these days are increasingly having to think about. Case in point, Something like Google. So a lot of us like to use white space, right? We've been taught it's good for readability. Hit the space bar, hit the tab key or whatever to nicely pretty print your code. Well, if Google does that on their homepage and hits that space bar one extra time, well, if they get 1 billion hits per day, that's 1 billion bytes. That's an additional gigabyte of traffic that they now need to send over the internet, compression aside, and that's just for one space character. So there's a lot of really juicy details that are increasingly becoming important, not because all of us get 1 billion hits per day, but most all of us are carrying or using devices like this, as are our users whose bandwidth is not as high, whose latency is much higher. And so now there's some interesting design decisions that you need to make yourself as a developer so that the experience on that device is as good as a faster, more souped-up machine. And at least this is a challenge that will be with us for some time. So we'll transition in lecture 3 of the course to XML. So at the end of the day, the course will focus a good deal on databases, specifically MySQL, one of the most popular and one of the most free options out there. But we'll first look at a much simpler technology, if you will, and that's an overstatement, XML, which for those unfamiliar, it's very much like HTML in spirit, but it is sort of make your own tags. And it's useful to be able to tag things with open bracket, something, close bracket, and with attributes and the like, because you can define really a sort of flat file, a text file, type database. If you don't really need the power and the sophistication of SQL, a language we'll discuss, or MySQL, the specific incarnation of that, sometimes just implementing a configuration file or a small few kilobyte, few megabyte database is wonderfully wonderfully well suited for just a local file, text file. Because if you're already writing code, storing it on disk, guess what? You already have your storage engine. You don't need to figure out how to install a database. You don't have to keep a database running. You don't need to consume the RAM that a database requires. So for the first project, we'll use not a real database, but we'll actually use XML. And not just the flat file itself, but we'll use some related languages, technologies. And there too, an overstatement, but XPath specifically. XML path language is a query language that, much like you're used to seeing file system paths like /user, /bin, or C:\program files and the like, with similar syntax, can you actually navigate hierarchically an XML file. And as such, you can query an XML file and get back pieces of data that you want. You don't have to go grepping through it or finding data yourself. There exist languages for this. In lectures 4 and 5, we introduce, for most unfamiliar, and also start playing with in great detail, SQL. This is a language that's used to interact with many of the most popular database engines these days, Oracle, Microsoft Access, MySQL, PostgreSQL, and a number of other options. And it's a language that we'll use to actually store data, retrieve data, search data, and ultimately back the final 2 projects in the course. And we'll look at some of the tools that are useful when actually using this database, specifically MySQL, yourself. And then we transition about midpoint, from things server side to things client side, whereby a lot more of the code you'll be writing is on the client side. That is, it's written in a language called JavaScript. Now, not too many years ago, JavaScript was an annoying little language. It was responsible for all of those pop-ups 5 or 10 years ago. I mean, it really didn't have all that many uses other than triggering alerts, opening windows, changing text on a window. But now it really has come into its own. And it is thanks to this language, or any client-side language, that we have things like Google Maps and the chat window in Facebook and any of these more sophisticated, more seamless user interfaces that grab data sort of unbeknownst to you and just kind of slip it in, let it fade in, as opposed to the whole page, 1990s style, reloading. You see a white screen, a white flicker, and some amount of latency, and then you see the next page, which isn't just badness for, say, user experience. It's also a waste of bytes. Why constantly get the same bytes again and again and again, caching aside, when you're only changing a few lines of text, like the most recent instant message someone sent to someone? So we'll look in this lecture 6, as well as in lecture 7, at JavaScript and a specific use of it, this technique called AJAX. And AJAX is the buzzword du jour that describes the ability of a web page, after it's been loaded, to go back to the server, sort of behind the scenes, and get more data. Consider Google Maps, the fact that you can click and drag and you don't have to do the old MapQuest approach of hit up, left, down, right to move around, and it just grabs Google Maps those additional tiles. You might briefly see a little gray square where there are no tiles ready for you, but it downloads them behind the scenes. And any of these particularly sophisticated UIs that you now see increasingly on the web, well, we talk about how you build those things and what tools exist to bootstrap those kinds of UIs. And in Lecture 8, we focus specifically on user interfaces. You can do a lot of bad things when you have just a little knowledge of HTML and PHP and JavaScript. There's a lot of horrendous websites out there, a lot of them by some of the biggest companies out there. One nuisance I constantly run into is even on something like Bank of America's website. I had to change my email address at one point, or start using a different one, because some programmer decided that mailin@post.harvard.edu is syntactically invalid. So not true, right? You can have subdomains in an email address, and this is just a hint that there's a lot of silly, simple, stupid, but also big picture design decisions that are constantly getting made incorrectly each day. And so as we go, we'll trip over and we'll discuss some of these little things that are all geared toward making ultimately a better user interface. Because the bar is increasingly being set high. The more sophisticated websites become, and the more, frankly, they become more like apps and less like static content that you just click from page to page, the higher the bar is being set for people who like to program and who want to work in this space. Finally, at the end of the semester, and this isn't to say we'll turn a blind eye to these topics throughout, but we'll really dive in deep at the end of the semester where we talk about security and scalability. Here, too, there's a lot of stupid mistakes being made by well-intentioned folks who but just don't necessarily understand, one, how the data is actually getting from client to server and back, and therefore, if you don't understand that big picture, make some very honest mistakes when it comes to defending their site or their servers against this. You hear about things like cross-site scripting attacks. You hear about SQL injection attacks. In fact, anytime you visit a site on the internet that has a form, you can kind of have a little fun with it. Type in something seemingly innocuous, like an apostrophe, a single quote, and hit enter. Very often, surprisingly often, bad things happen because, why? Anyone know how such a simple little byte can cause havoc?
SQL doesn't like
single quotes. So this language SQL, if a website is not just serving back static content, but is taking user input via a form and doing something with it, maybe passing it to a database and back, if they are passing it to the database using quotes that the developer typed and didn't really anticipate that you might insert some lone quote there in the middle that can completely break syntactically what they are passing to the database, and best case, it just gives you a stupid message and there's a problem and the user has to reload or something. Worst case, they put something like single quote, delete from star. And that's kind of bad because this is what's known, and we'll look at this in more detail, a SQL injection attack where your innocuous user is not typing the apostrophe by accident, but it's because they want to terminate the thing you were typing, inject their own thing, and then let the database go on about its business. And this happens surprisingly often. And the irony is, at least in PHP, one function call can fix all of those problems, at least the ones we just described. So we will tell you about those in Lecture 9. We'll see it sooner. And finally, in Lecture 10, we look a bit about scalability and how you actually build websites, not necessarily of Facebook scale, MySpace scale, these kinds of things, because we would be fortunate, perhaps, in jobs and whatnot to have those kinds of problems. Probably doing pretty well if those are the problems you're facing. But even on a smaller scale, where you just have a few hundred users, or you have even few users, but tens of thousands, hundreds of thousands of database records, that's not uncommon at companies. There's some very interesting design decisions you can make along the way that can affect your experience in coding it or your user's experience in actually using it. So with that rapid fire overview of the course, any questions about content perhaps thus far? Anything at all? No? All right, so let me take a step back now and say, what qualifies you to do all of this? So the course is actually fairly liberal when it comes to prerequisites, because the reality is a lot of this stuff can be picked up relatively quickly. But again, it'll be our job as teachers, myself and the teaching fellows in the course, to do our best to make sure you learn it quickly, but also well. And so in terms of prerequisites, a typical student in this course, in fairness, tends to be a software developer or taking a bunch of courses and is perhaps looking to branch out beyond their current professional comfort zone and so forth. But we also have a lot of students each semester who've taken taken just one semester, maybe 2 semesters of computer science or specifically programming. At the extension school, this would be something like Computer Science E50A and or Computer Science E50B. In general, if you're coming at the course and you just know website design in the sense of HTML and CSS, you can absolutely pick up these things. But if I say things like for loops and functions and methods and hash tables, and you're feeling like it's kind of up here right now, it's a solvable problem with a little more effort than your fellow classmates, but realize we need to be able to, in the course, use jargon like that and assume that most everyone has used or heard of these techniques before. But at the end of the day, it's your choice. I would say it's best if you do have at least 1 semester of experience of programming in some form, not PHP, but Java, C, C++, whatever, anything fairly modern and syntactically similar. But feel free to consult with me or any of the teaching fellows during break today or after class or over email. In terms of expectations, pretty much is a project-based course. So we have the lectures here, which if you're local are available to you attend. If you are distant, you can watch them on the video cameras that we're using to record film here. Lectures when filmed. Ironically, folks watching this at home won't know this until we actually do this, but we'll have them online usually within 72 hours, if not much sooner, and you'll have them in streaming and downloadable video formats as well as in MP3 audio formats if of interest. And we will always post on the course's website all handouts and such, including slides like these, which are generally just talking points and not really meaty things that we tend to print out, and the syllabus is already there itself. In terms of projects, there will be 4 assigned projects whereby we write the specs and we challenge you to implement. The first of these projects is actually pretty low-key. It's going to involve, in 2 weeks' time, we're on hiatus next week because of the holiday, so it's kind of a gentle start to the term. But the first, Project 0, will involve buying your own domain name if you don't have it already. $9.99, $6.99, $29.99 if you get some kind of vanity domain, but fairly inexpensively. We're going to walk you through the process of configuring something called DNS, more on that tonight, to point your domain and some subdomains therein to our cluster of systems, the so-called CS75 cloud, which is a bunch of servers here that will host your websites on. We'll provide the databases ultimately that you use. If you don't know what a database is yet, not a problem. We'll get there in a couple of weeks' time. But in short, that first project will have you pretty much get that domain name, tell us what it is so we can tweak our server's configuration so that we know to host your website here. You'll get a username and password. And the first assignment will pretty much involve making the equivalent of a Hello World website. Very simple HTML and CSS, just to make sure that you're ready to go for the first real Dirty Hands project, which will be Project 1. The 3 projects thereafter, 1, 2, and 3, will be very much hands-on, involving PHP, ultimately XML, MySQL, JavaScript, Ajax, more on these as time passes. And I would say in terms of time allocated, you generally have about 3 weeks for each of these projects. Do not, and we can say this ad nauseum, but don't save them till the last weekend, because inevitably that takes some of the fun out of any course. They're really meant to be chipped away at over time. That first weekend to dive in, read through it, think about what you're going to do, even if you don't start coding it till the second week. Definitely use that time. And the variance is high in terms of how much time the projects will take. Some students might take 10 hours if they are particularly savvy, maybe really have a solid background. We generally expect 20, 30 hours per project, but again, spread out over at least 3 weeks, and sometimes more, 40, 60. It really depends on your background and, frankly, just how into it you get. I find myself personally spending way more time than I allocate on projects just because I realize, that would be a really neat feature, and then 8 hours later it's working. So we'll see what happens here. And then a final project. So the climax of this course is to implement your own final project, whereby roughly 2/3 of the way through the term, you'll propose a project to myself and the teaching fellows so that we can then adjudicate its scope and decide yay or nay, this is consistent with the course's goals, this should take an appropriate amount of time, and it will be your challenge to execute at term's end, so that you all have a chance to reconvene and also meet perhaps some of those of you who are tuning in from home. The course culminates in the computer science fair, as we call it, whereby we join forces with a course called Computer Science E7, Exposing Digital Photography, which is very much also a project-based course, though very different. Those folks take photos and they put them on the web. We kind of make the websites that they put the photos on. But we'll join forces over some soda and cake and have a little exhibition on laptop screens and the like, where you can then demo to yourselves, to family and friends who might want to join, to the other class, the projects that you worked on in those remaining weeks. So it's a nice way to sort of wrap up the term in a bit of a social sense. All right. Any questions then? Structure or otherwise? Yeah.
For that first project, where you need to give you a domain that you'll register for database setup and all that, can you use a subdomain if you already own a domain?
Yes, so that will be fine. If you already own a subdomain, that's fine. We'll walk you through the process as best we can, not knowing who your registrar is in advance, of how you can set up one or more subdomains that themselves point to our website. So you don't have to shell out the additional money or just pollute your account with more domain names. You can absolutely use subdomains, so long as we know what they are. And again, the spec that you'll get in 2 weeks' time, 2 Mondays from now, will walk you through all these steps. And we'll talk about the big picture of it tonight. Yeah? Good question. The final project, we do allow collaboration with 0 or 1 classmates, but for the 4 assigned projects, they're meant to be done independently by students on their own. And for clarity, I'll refer to the last page of the syllabus when the time comes. The course's policy on academic honesty makes very clear, to the extent possible, where that line is between chatting with students and working through problems and crossing that line. So more on that in the syllabus. Other questions? Yeah? Yes. TBD. So sections, for those unfamiliar, are opportunities to adjourn to a smaller, more intimate environment with a teaching fellow present. We have a number of teaching fellows for the course. We have photos and email addresses online, and they'll make cameos tonight and in future lectures to say hello. But a section is, aka recitation. It's an opportunity to get together with maybe 5 or 10 of your fellow classmates and ask questions that you might not feel comfortable asking in a somewhat larger room like this, or exploring some material from lectures in more detail, talking more specifically about that week's project and strategies for tackling it and the like, and going over some additional examples beyond what we have time for in lecture. What we will do is circulate between now and next Monday, most likely a survey of sorts, a form, via the email address that you registered for the course, asking for preferences. Inevitably, we can't make everyone happy, but we'll do our best to pick 1 or 2 days and times that work for an optimal number of people, and we also will record one of the sections on film so that those of you playing along at home or who just can't make that day time at least have a videotaped option available to you. And the email you received from me, hopefully, this morning went to the official email address with which you register. What we're going to do so that you have opportunities to reach out in a communal sense to each other for chatter and to the staff with questions that are appropriate for other people to see the answers to and might learn from as well. We've set up a Google group whereby we'll circulate via an email from me to the address of this. You'll just click subscribe to this account. You can use a Gmail account or any email address so long as you sign up for this specific Google group. And it's nice because for those unfamiliar, you can either choose to get 1 email per post, you can get a digest per day, you can get no emails at all and just proactively check a web page when you want to see. And we'll use the Google group really for questions that are not so much, here's my code, help me find the bug. It's a little too personal, a little too individualistic. We have a separate email address for that that you can email to the staff, and we'll talk more privately. But for general techniques, for problem solving when it comes to configuration issues and the like, we make good use of the Google group. And it tends to be a nice way of reaching out to other students, and you start to see some familiar names. And just last semester, a nice tradition of students adjourning to the square for dinner or drinks afterward happened. So we'll see if we have the personalities to drive that this semester. Other questions? No? All right. So let's tell a little story and perhaps cover some things you already know along the way, but also hopefully fill in some blanks and talk about really the domain in which we're going to be playing this semester. So to come up with an arbitrary starting point, suppose I am someone who wants to make him or herself a website. Or maybe more commonly in this room, suppose you are a person who knows how to make websites, but someone has come to you asking you to make their website for them. And so part of that means not only writing the code, say HTML, CSS, but soon PHP and SQL queries and so forth, but you also need a place to put it, right? Because this is a mom and pop shop, for instance, that just wants to sell their widgets online. They might have an internet connection, but they don't have a server. They don't have a static IP address because they just have Comcast or Verizon or something like this. So you need to solve a few problems. You need to, 1, build that website, and we'll talk this term about how to do things like that, but you're first going to need to get them that domain name. You're then going to need to map that domain name to a specific geography in the world, a specific server, and then you're going to have to make sure there's actually a server there. So let's discuss what some of those options are and what some of the underlying implementation details are so that you yourself can execute precisely this, whether you're for yourself or for someone else. So suppose that, we need a trivial little picture, suppose this is me somewhere in the world on a laptop, And suppose there's this amorphous internet between me and, say, some company, let's call it Google, that has servers somewhere in a big building, and this is what we'll call a client. And somehow I'm connected to the internet, wirelessly, wired, whatever. Doesn't really matter, but I have now a point A and a point B on the board. They're wired together. How, though, does traffic actually get from point A to B? What protocols are involved? And more importantly, who cares? How is this actually going to benefit us? We'll look in a moment at some tools that actually are germane to this. So I pull up my operating system here. I boot up. I open my favorite browser, and I type in google.com, and I hit enter. And, fairly open-ended question, what's one of the first things that next happens inside of my computer for something useful to occur? I hit enter. What happens? It looks up the domain name. OK, so I have typed into my little browser's address bar the human-friendly form of an address, www.google.com, or just google.com. So that's insufficient detail to actually get from point A to point B, because the world, as you know, the world's internet is driven by these things called routers, really big fancy servers that pretty much take data in and then send it that way, or maybe send it that way. They literally route information. Sometimes they're called gateways, if you see that elsewhere. So routers, though, for efficiency reasons and just sort of sensibility implementation reasons, don't use domain names or host names or fully qualified domain names. You can kind of interchange these terms. Doesn't really matter, but there's subtle distinctions. Things like google.com, they don't deal in those pieces of jargon. They instead deal with IP addresses, numbers. So an IP address is a number of the form w.x.y.z, and each of those placeholders is a number from 0 to 255 with some restrictions. So in total, you have a byte, dot, a byte, dot, a byte, dot, a byte for a total of 4 bytes, or 32 bits, which means there's as many as 4 billion IP addresses available in the world. As an aside, a lot of people are worried that the sky is falling because we're really running out of IP addresses, at least with these 32-bit addresses. So more on that as we discuss scalability and the like. But thankfully, there's a solution. Just not terribly many people have adopted it yet, but we'll get there. So I type in enter. I hit enter. My computer now needs to translate this name, google.com, to this thing called an IP address. And much like 33 Oxford Street, Cambridge, Mass. 02138 uniquely identifies a building in the United States for the Postal Service, similarly does a number uniquely identify, small white lie, a server or a computer on the internet. And really what these routers know is that any IP address that starts with 1.2, I'm supposed to send it that way. Any IP address that starts with 3.4, I'm supposed to send it that way. And so they use these fairly simple heuristics, these lookup tables, to figure out what direction the data is supposed to flow in. Now, I, the user, really don't care. But why is this now relevant to the story? Someone needs to do this conversion for me. And odds are my little old Mac or PC does not have a big exhaustive database of all 4 billion IP addresses and the corresponding domain names or host names. So my computer, whether it's running Windows, Linux, Mac OS, whatever, needs to ask for help. And what's that server called that my computer asks to do this translation? So these things called DNS servers. So somewhere in this picture, probably around here in this picture, is what's called a DNS, domain name system server. Now, whose is that? It's probably not something I myself own unless I'm running a company. It probably belongs to my ISP or my employer, Comcast, Verizon, Harvard, or whomever. And this server lives pretty close to me on a network. And when I send out this request for google.com, it's that server or some set of servers that are supposed to reply with the answer, 1.2.3.4 or whatever. Now, very possible, especially if this is a small fish ISP, that this DNS server also doesn't know what google.com's IP is. Now, unlikely, but if it's foo.com, maybe they don't yet know. So what happens if Verizon's DNS server or Comcast DNS server has no idea what you're talking about? What happens next? Yep.
Ultimately, they go with top level DNS server.
So exactly. So there's a hierarchy built into DNS, and this is what This is what makes it all work at the end of the day, in that if this guy doesn't know, he asks this guy. If he doesn't know, he asks this guy. And then so forth. You can have this recursive process where at the end of the day, thankfully, there is a relatively small number of authoritative domain name system servers that do know who knows what all of the .com mappings are, for instance, what all of the .gov mappings are, for instance. And then so you can have perhaps this chain of requests that go da-da-da-da-da-da, and then he says, oh, this guy knows. Then your request goes over here. And finally, do you get the answer for google.com, foo.com? It comes back to this DNS server. This DNS server, if it's smart, caches this, so it doesn't have to go through all these tedious steps again. So the next time my sibling or whatever requests the same web page, I don't have to go out on the whole internet getting back that map between IP and hostname. It's already living here. Now, gotcha here, and one of the issues we'll already trip over tonight, that's great. Caching in general, wonderful principle. It's what actually makes websites scale in general these days, but there is a downside. As a little teaser, is there any glaring problem with this idea of having that guy cache that IP address? If your IP address changes. Now, this might not happen very often, but it definitely does happen. And when it happens, it can be painful, especially if your website is, as we say in this course, dynamic, uses some kind of database that not only reads from, but also writes to. This is problematic because now, if you have to move your IP address, it's kind of hard to move everyone on the internet at once to the new server because some of those people might have remembered your old IP address, which suggests you have to leave your server up in two places, but now you have two databases. How do you synchronize these two things? Do you just redirect someone to a new temporary domain? Whole lot of headaches arise, in which case some advanced planning can certainly help with these things. So more on that too as the term progresses, also in scalability. But for now, we're just going to assume this is a wonderful thing. I now know that google.com is 1.2.3.4, so my operating system sends out a subsequent request, this time addressed to, not the local DNS server, but 1.2.3.4. If we're thinking of this as like a little envelope in the mail system, the return address would now be my IP address, my client, which lives over here. And now I send out this request to the internet, and it goes from router to router to router, and each of these guys is pointing this way, this way, this way, and hopefully within some small number of hops or steps does that packet reach google.com. Now, I just said packet. So packet has technical meaning, but for our purposes, it's just this envelope with some kind of request for a web page. What does that request look like? Well, what language does a web browser and a web server speak with one another? So HTTP. So piece of jargon you might have taken for granted for years now by typing it into URLs or having it typed for you by your browser, but it actually does have some specific meaning. So the traffic that goes back and forth here is indeed called Hypertext Transfer Protocol. And this really is a fairly simple language. There's only a few commands that we really care about, at least from a developer's perspective. But this is just a language that browser and server speak. It's a set of, it's a protocol, literally, that two devices speak. And what do we mean by protocol? Well, in the human world, when I meet someone, I might say, hi, my name is David. Well, now's your chance to say hello. Ricardo? Okay, nice to meet you. So we have this protocol, maybe a silly human convention of like shaking hands and saying, hi, how are you? And, you know, I care here, but you don't usually care. And this is what computers do, too. They initiate a connection. They have some set of jargon that they exchange so that they get the connection going. Well, what's the request that's being made here? Well, in its simplest form, a web browser says get, and then says, what do you want to get? I just want the root of your website. So cnn.com / google.com /. So I'm just going to say /, but it could be a longer path or file name. And then I mention what language I'm speaking, HTTP 1.1. It's pretty much the current standard. And that small white lie is it. That's what's in this virtual envelope that's sent from client to server. So when google.com receives this at its own IP address, 1.2.3.4, a piece of software there opens up that envelope, looks inside, sees this message, and realizes, oh, I, being the web server now, need to return to this user /. Well, what is that? It differs on systems. If you've designed web pages, you probably know / generally implies index.html, index.htm, default.asp, default.htm. Totally varies on the web server, but there is some standard. Let's assume for now it's just a file. It's a text file filled with HTML, maybe some CSS, some JavaScript, whatever. The server reads those bytes in from disk, writes them out to the network, similarly addressing them to my IP address with his return address. They then reach their way to me, and voila, when I see google.com search page, that is the result of having been handed in the response envelope, all of that so-called HTML that my browser reads from top to bottom, left to right, renders on the screen. Connection closes, which has interesting implications for performance and scalability for the most part, usually closes. And then the little icon stops spinning and done. And I point this out now to say that HTTP is what we'll call a stateless protocol. Unlike something like SSH or FTP or other protocols that constantly maintain an active internet connection, the curious thing about HTTP is that you make your request, you get your response, and for the most part, that's it. Connection closed. All of the underlying TCP and IP stuff, if familiar, closes down. And the connection stops, and the fact that that thing is no longer spinning, the icon, means your browser is no longer talking to the server. You could unplug from the internet, walk away, and so long as you don't close the window, you can still see those contents. Well, this is good for scalability. Web requests tend to be fairly small and bite-sized. If I'm only talking to the server for a split second, a whole lot of people can probably talk to that same server in that 1 second. But now that websites are increasingly dynamic, now that you get little chat, instant messages on sites like Facebook, if you're on eTrade.com, you're getting streaming stock quotes. This suggests that you're constantly getting more and more information for the server. So one of the questions we'll look at midterm when we look at AJAX and JavaScript and the like is how do you actually implement state and maintain a constant stream of information efficiently when the whole purpose of this protocol, because of this protocol HTTP, was to call it quits after it made a single request. So we'll look at the A in AJAX, asynchronous, as to how you make subsequent calls again and again and deal with them coming back, perhaps out of order even. So any questions on this story involving points A and B and a little bit of DNS and HTTP? Anything at all? All right, so let's scroll back in time to when Larry and Sergey first started Google.com. They weren't just handed this domain name, they needed to buy it. And the curious thing now is, well, even they perhaps struggled because this is kind of a fake word based on a different word that's spelled somewhat similarly, numerically. But these days, frankly, it's so silly, but one of the hardest things about like starting a website if you have some pet project is just finding an available domain name. Most of you in this room, if you've ever done this, have probably tripped over just how many squatters there are out there. So how are people like they and how are people like us supposed to go about buying a domain name? Well, for those who've bought domain names before, what registrar, as they're called, have you used? Any random? What's that? Network Solutions, pretty much the first, still around. The market is now open to other options. What's that? Gandhi. Okay, another option. One-in-one. Bluehost. GoDaddy is, I think, now the biggest. I tend to talk about it a lot because I just kind of got ingrained there myself a few years ago, and I love some of the tools they provide. It is a scary example of constant attempts to upsell you at every point. Want to buy a domain name? Sure. Do you want also a server with this? 10 email accounts? Spam protection? Oh, one of the hardest parts, frankly, if you've never bought a domain name, is to fight your way to the shopping cart just to actually check out, because most of these folks make more money when they sell you services whose marginal cost is very low. But we won't mandate that you use someone. Oh, wait. I don't know why GoDaddy came up last. The answer's right there. GoDaddy is I think the biggest now. They tend to have good prices, but you got to beware because you buy domain names on a yearly basis, or you can pre-purchase multiple years, but then they stick you a year or 3 years later when they up the prices a little bit, whether it's because of Network Solutions or other companies that are involved in the process. But it's relatively simple. So when you need to buy a domain name, you first choose a registrar. Odds are you go with the biggest one you've heard of or what a friend tells you to do. If you've already got one, stick with it because there tends to be the utility of using the same interface for all your websites. You usually choose your domain name. Let's just do this randomly just to give you a quick mental picture. If unfamiliar, I'll go to GoDaddy just out of personal bias. And you got to be careful too. I don't think I've ever gotten a domain name for $1.99 because you usually have to get something like .me or .biz or .something that you're not wholly comfortable with. But let's go ahead and start your domain search. So let's do something like let's try lemonadestand.com. That would be a good one. All right. So I can have not lemonadestand.com, but .co, .me, .ws, .cc, .asia, lemonade backorder. Okay, so this too is kind of an ongoing scam. Backorder, you never get it. But in any case, whichever registrar you choose, and the spec for Project Zero will hold your hand a bit through this process, though it's really the implementation details will vary based on whom you choose, you'll buy a domain name. And that generally involves clicking a link like this, adding it to your shopping cart, deciding what price point you're comfortable with. For the course's purposes, you certainly don't have to spend more than like $9.99 plus tax, but depending on the domain name you choose, it may in fact cost more. What you'll find is that even even though just a few years ago, you really could only choose from like .com, but also .org, .net. Contrary to popular belief, anyone can buy these domain names. You don't have to be an organization or a network. They were very long ago broadened in scope. .edu kind of need to be a school. .gov kind of need to be the government. And similarly for other countries, are there restrictions on what domains or second-level domains can you actually buy? Just to give you a sense, though, the market has really kind of opened up. Whether or not you want to use an address like this is really up to you. There is an interesting social or marketing aspect to it, whereby I don't mean to offend. .biz always feels to me, a technical person, like .biz. Kind of feel like you want to try a little harder. But it's a stupid, just mental blockage, because the reality is it's getting increasingly hard to find addresses. But at least for companies that target somewhat non-technical people, there's a utility in having something like .com, even more so than .net or .org, which are just as accessible to us, is because someone like I violate this rule every year. I'm not supposed to use family in examples, but my mom knows that something.com is a website, whereas something.co or something.ag or com.ag looks a little weird. They might be averse to click through. They might be averse to buy my products, and so there's some real world issues. For most people in this room, probably this is a non-issue. And in fact, if you want to go with .ag because you can get it for $1.99, by all means, go for it. The funny thing is, for those unfamiliar, is that any of the two-digit characters, .us is for United States. There's a lot of two-digit TLDs, top-level domains, and they actually belong to companies, even though we, English-speaking folks, tend to abuse these. So we, for the course, have an archive of open courseware for this course, videos of several past semesters, handouts, and the like. And just because we thought it sounded cool, have CS75.tv. The idea being you can go there and watch all the videos from the past several years, as well as this semester soon. But TV does not mean television. It's because a small Pacific Island nation called Tuvalu decided to sell their domain name to the English-speaking world and other countries that use the acronym TV for television, or the abbreviation for television. So there's many, many examples of this these days. It really depends on what you're comfy with. So it doesn't matter to us what you ultimately go with. So you add this to your shopping cart, you check out, and you receive an email confirmation at some point saying you now own this address, this domain name, at least for a year or so. What happens next? Well, it's not enough to just buy the domain name, because now you've bought it, but the whole world does not know it exists. So you next need to actually tell your registrar, Network Solutions, GoDaddy, Bluehost, whoever, what the name servers are, what the DNS servers are that are going to map your domain name to the one or more IP addresses that ultimately are going to correspond to it. So I used one IP address for Google. In reality, they have a few that are publicly exposed for load balancing purposes. And even you might have multiple IP addresses for multiple servers within your organization. So you need to tell GoDaddy or Bluehost or whomever what the IP addresses are, or what the host names are, of the DNS servers on the internet that themselves will know how to map lemonadestand.com to an IP address, foo.lemonadestand.com to another IP address, bar.lemonades, and so forth. So how do you decide what name servers to use? Well, generally, you first choose a web host. Now, this might be your own web server, but for the most part, and for a course like this, unless you're running your own infrastructure, odds are you're just going to outsource this. You Google around, you ask for recommendations, and you pay someone on a monthly basis, generally, for a web hosting account. What does that mean? For those familiar, it could mean a shell account. You can SSH to it, SFTP, or so forth. More commonly, especially among the smaller offerings, you get like a web interface, so you can write your code and whatnot on your own machine and just upload it via a web-based upload utility to the server. And any configuration you do of your website, you do via their web panel, as they're generally called. And you pay some number of dollars per month for these capabilities. One of the most popular options out there is a company called DreamHost. And there are many, many, frankly, just to give you a sense of this web hosting company, this is one of the most saturated markets out there. If you flip through this, frankly, the best heuristic here is to go with someone that someone you know is already using, so you have some level of comfort as to quality and reliability. The catch, too, with web hosting companies, as we'll discuss later in the term when it comes to scalability and actually implementing web infrastructures, anyone can start a web hosting company. All you need is a single server and freely downloadable software to virtualize that server or to create multiple user accounts on it via the web. And so what you get, really do get what you pay for. If you find a web hosting company that's going to sell you web space and a whole lot of gigabytes for $2 a month, it's a great deal. But ask how many days in the month the website's going to be up, and ask how many other people they're selling that same amount of space to, overselling their capacity. So this is very common. And even I've learned the hard way, choosing companies poorly to host things, is that sometimes my own website slows to a crawl because other people's websites are running on their server and they're just overusing their share of resources. Partly because some companies don't even put hard bounds on the resources. They just assume that on average everyone's going to kind of use the server equally. And if they don't, we'll deal with it later. But we'll discuss that option in just a moment. So cheesy looking website. But what's interesting is that if you go to this list, they really do throw in the kitchen sink these days. But again, you got a caveat emptor here. So in terms of, won't fit perfectly. There we go. So in terms of DreamHost, which is among the most popular out there. And to be clear, the course provides its own infrastructure, not something you have to pay for. We'll host it on our cloud setup. You get 50 gigabytes of backup. Oh, disk storage, unlimited terabytes. That's interesting how they pull that off. Domains hosted, unlimited, full shell access. That's actually useful, and we'll see that tonight and in the weeks to come. How many email accounts you get, what OS it's running, if that's relevant to you, email accounts and all this. You really do get an amazing array of options. And if this is for your own little home pet project, kind of a smaller website that, if it's not up 99.999% of the time, it's not a deal breaker, kind of hard to beat $2 a month, then maybe these options are fine. These guys, I don't know what they currently charge, $9.90. Oh, no, that's not it. They charge upgrades. What is the starting price? $8.95 per month. But here, too, as an aside, lest you think this is just an advertisement for these companies, I stopped using them because of a bad experience. But they're very popular, and most every one of my friends still uses them for these things. So the lesson really is to know what questions to ask, and that'll be one of the takeaways tonight as to what pieces are involved in web hosting. So you choose a company. You sign up for an account. That means you have a username and password that you can access their web-based interface on, or you can use SSH or SFTP, things we'll look at in the course. And so now you can start uploading your content. Well, that company, DreamHost or whoever, will tell you what the addresses are of their DNS servers. In this case, it's like ns1.dreamhost.com and ns2.dreamhost.com. The ns1 and 2 is a common convention these days. So what you do, after you've chosen your web hosting company, is you go back to your registrar, you find whatever account page they offer to you, and you type in the appropriate field, ns1.dreamhost.com, ns2.dreamhost.com, enter. So now, maybe after a few minutes or hours, the next time or the first time little old me pulls up lemonadestand.com, Comcast, Verizon, whoever's DNS server is not going to know. So my request might propagate way up here to the so-called root servers, but those root servers do know who knows where all of the .coms mappings between host names and IPs are kept, and that's what your registrar just did for you. The fact that you told them whose DNS servers you are using means they can now answer recursive queries of that form. And now that information can get disseminated and cached all over the internet, for better or for worse. And now you're up and running, except you need to now make sure that the web server is actually running. So step 1, buy domain name. Step 2, choose and pay for web host, except in our case where we'll give it to you. Step 3, tell the registrar what your DNS servers are. And then step 4, implement said websites. And now you're up and running on the internet. So whirlwind tour, but pretty much all of those steps will you do yourselves, where we, the course, take on the role of web hosting company. And what will be nice, too, is for those of you who are coming into the course with the goal of building projects, especially for your final project that you actually want to use afterward, or as a prototype or as a real-world project for work or for personal purposes, you should find it relatively easy to move your stuff off of our servers at semester's end to your own server or to a web hosting company, since we'll keep things as standard as possible. This really isn't a sandbox environment. What you will get is something pretty comparable to the most flexible of web hosting companies. You'll just need to tell us what your domain name is so we can tell our web server to expect requests on the internet for your domain. Any questions? Anything at all? All right, so that was a whole lot of words. So why don't we go ahead and take a 5-minute break. I'll linger up here if you have more personal questions, and we'll resume in about 5 minutes. There's bathrooms and water fountain upstairs. All right, we are back. So a word on resources that the course offers. So there's no required books. Frankly, there's so much information online. You certainly don't need to incur the expense of textbooks. But if you are the type who likes to have that resource in your hands, likes to have reference books after the course, we propose two different sets. So one for the students we playfully call those less comfortable, and a different set for those more comfortable, and that kind of means what we say. So for students that don't necessarily have the strongest backgrounds, might not have some formal computer science background, we found, and I personally have found, that these are pretty good books. They're pretty user-friendly. There's not too many words on each page, so it's very digestible, and the page teaches you what it says it's going to teach you in terms of the title on the top. It's frankly just very easy reading in a good way. These aren't like fluffy picture books. They're actually technical, but they're easily digestible, more so than some books that are this thick for no good reason. So you might want to take a look at one or more of these options. You should find them either at the Coop or, frankly, go online, Amazon, buy them used if you're going to do them. And we've also put them on reserve at Grossman Library, which is the Extension School's library across the yard in Seaver Hall, top floor, if you want to take a look at them there. One is on, if you can't read the text here, HTML, XHTML, and CSS, PHP and MySQL, and JavaScript. In terms of the particulars, essentially, we have relatively few design expectations in the course. We don't care about your particular choice of CSS and colors, and all of this isn't so much a graphics designs course as it is a programmatic course, an implementation course, design of code underneath the hood. With that said, we will set certain bars for each of the projects whereby your code must at least be valid HTML 4.01 or valid XHTML 1.0 or valid HTML5. So we will set some technical thresholds really in the interest of pushing more and more people toward actually adhering to standards, which generally just makes the world a better place. Even if you don't love the standard, it's just nice when things work the way they're supposed to. But more on that as things advance. If unfamiliar with these particulars, it's not a big deal. And frankly, one of the most useful things about setting that kind of bar is you can go to validator.w3.org, and this website in particular will tell you if your code is syntactically valid. Now, with that said, in the real world, sometimes you need to break validity to actually accomplish something useful. You really need to embed that tag that isn't necessarily valid. With JavaScript these days, you can completely circumvent the idea of validity and insert stuff into the DOM, as we'll call it, in the weeks to come, completely arbitrarily. But we'll discuss this as the first project itself comes out. For those more comfortable, different set of books. They're a little smaller, they're a little meatier, but perhaps slightly better reference books. Whereas the first set you might kind of read once and digest for the most part. These you might flip back to a little more, but I'm kind of making this up as we go. So these books here are targeted also on some lower level details that you don't necessarily need to dabble in the course, namely Apache and Linux. But what we will do starting with Project 1 is you'll get an account on or with Project Zeros, you'll get an account on cloud.cs75.net, which is a cluster of Linux servers on which you'll have a username and password. We, the sysadmins for the course, will run the web server software ourselves. You'll have a user account, and we'll tell you exactly what naming conventions you need for your directory so that your domain name maps to the files in that particular folder. But what we find every semester is that a lot of students, rightfully so, would prefer to do their active development not on our servers, but rather on their own laptop or their own desktop or on their own web server. And that's perfectly fine. What we're offering, too, for the first time this year is what we call the course's appliance, a downloadable virtual machine, whereby you can download some free software. It's a few hundred megabytes, but it's a Linux installation prefabbed for you. So you download a hypervisor called VirtualBox. For those familiar with Parallels or VMware, it's a similar option, but perfectly free from Sun Microsystems, now Oracle. It works on Macs, PCs, Linux, Solaris. It's really nice and cross-platform, and again, free, and it works quite well in its latest incarnation. And so with this, can you actually boot your own environment that's configured almost exactly like cloud.cs75.net. And what's nice here, especially if you really want to get your hands dirty, in that VM will be your own web server and your own installation of PHP. And you can configure the actual configuration files that generally web hosting companies don't let you tinker with because they do things on scale for lots of people. So if you're the tinkering type, if you really want to get as much technical content out of this as you can, you might want to dabble either with your own installation of the various software packages we'll talk about during the term, or download them that we've set up for you, so at least you can break things on your own. And frankly, you can't do much damage, because worst case, you just download a new VM and you're back to square one. But at the end of the day, as you'll see in the specs, all code that you write must be submitted to our servers, and they must actually execute properly there. This is going to be the kind of detail per the spec that you're not going to want to leave to the last minute, because if you've done something silly like hard code a path that exists on your system but not ours, things will break. And the fact is, this is a very real-world problem to be solved, actually getting your code to work on another platform. But the beauty of the technologies that we'll be using in this course, MySQL and Linux and Apache and all of this, is that they are all fairly portable, certainly between Linux environments. Another popular option, if you'd like to start tinkering or Googling at some point this week or next, there are other options. XAMPP or XAMPP is a package that exists for Macs, PCs, and I think also Linux. This is essentially a downloadable executable where you double-click and it installs for you Apache, which is a web server, probably the most popular, free, pretty high-performing web server out there. Alternatives for the unfamiliar, things like Microsoft's IIS on the Windows world, Lighty on the Linux world, Nginx on the Linux world, and dozens of others, but those are the biggest names. What's nice about this is that you get all of these various packages. What is the X? No, I always forget what the X stands for. But Apache, MySQL, PHP, and also Perl. So they install all these things for you, so you don't have to go to like 5 different websites, bang your head against the wall trying to get them all to work together. In theory, they all work together for you out of the box. With that said, inevitably, one or more students have some weird quirk to their setup, and they end up banging their head against the wall anyway, which is why we've moved toward this model of promoting a virtual machine, which works the same for everyone, everywhere, because it's in a virtual environment. But another popular alternative is MAMP, which is essentially the same thing, but someone else's implementation of that idea. Useful to know, if only because for maybe your real-world jobs, if you ever need a LAMP environment, all of these things play off of the idea that we have in the course catalog description of LAMP, Linux, Apache, MySQL, PHP. In and of itself, it means nothing. It's just someone realized all these things that a lot of people tend to use at the same time, spell a word, and thus was born LAMP. But these packages just install all that stuff for you. And it's useful if you travel a lot or if you just like to work offline a lot. You can just, again, install all these things at once for yourself. But it's the same software you'll generally find available to you on web hosting companies. So what about our own website? Well, at the moment, some of you might have started playing around, but on the course's website will be links to the videos each week, a few days after they're actually filmed here. The syllabus is already up there. We've got links to resources, pretty much recommended readings, if you will, or at least some references on the web that we consider to be decent alternatives or superior alternatives to the recommended textbooks. Under software, do you have links to anything that you might need to download during the term, including a few tools that we'll take a peek at tonight, and also anything related to sections, including the schedule thereof, once we figured that out via an emailed survey, links to contact information and the like. And again, with the Google group, we'll circulate an email this week so that you know what the address of that will be. Any questions? No? Okay, so DNS. So let's get slightly more technical now, because I kind of waved my hands at some of these details, and it turns out that once you actually know who's hosting the DNS servers for your domain name, you actually now can start creating various DNS records, as they're called. And different records do different things. And the only one we've looked at thus far is not by name, but it was, in fact, the NS record. When I mentioned you tell the world what your website's name servers are going to be, you essentially create what are called NS records, so that those actually can inform the world thereof. But more useful on a daily basis or occasional basis are the 3 above that, MX records, CNAMEs, and A records. So let's pluck off the quickest one first. MX record stands for mail exchange, and this is the type of record that informs the world what the IP addresses are of your mail server or mail servers. This is to say that you don't have to host your email at the same physical server or the same IP address even that your website lives at, or whatever other internet services you are running. So generally, with an MX record, you will install, just check one thing. Generally, with an MX record, you will install multiple records, and they generally have numbers corresponding to them, where you'll say MX record number 10 is this IP address. MX record number 20 is this IP address. And what that means is if the world is trying to email someone at your domain name, their computer, much like our story here, asks for the IP address of your mail server. They get back the first record, number 10, and they then try to send the email to that address. If it doesn't respond, guess what they try next? Number 20, maybe number 30, number 40, and the numbers tend to jump in increments of 10, mostly by convention, sort of basic style where there's wiggle room in the middle if you ever want to insert some others, but it's generally 10, 20, 30, and so forth. And this allows you now to have multiple servers ready and waiting to receive email for your domain or your subdomains. You can have records for subdomains as well, much like I have for post.harvard.edu. That's a subdomain with its own DNS record or records. So you pretty much set that up once. It's worth mentioning now, though, because per my comment earlier about how increasingly easy it is to just wire things together to solve problems that you have, doesn't even need to pertain to code. Frankly, again, not to get on a soapbox about a particular product. Well, this one I actually like. The others that I've promoted I don't like so much lately. But Google Apps, for those unfamiliar, Google has increasingly started opening up more and more services that are already free to consumers to companies as well for different levels of packages, some of which are free and some of which are only like $50 per year per user, which is a huge savings for a lot of people over investing in operating system licenses and mail server licenses and human labor involved for actually running your own mail server. So for instance, what we do for CS75 starting just this year is we used to run our own mail server, and we had all of our DNS records point to our own server. We hosted our own mail. We had our own spam filtering. Complete headache, and such an uninteresting problem these days. The world has come up with many more interesting problems in the tech space for people to play with. And what's nice about someone like Google Apps is that we go on google.com and find the appropriate link. We then sign up for an account, and we say, I want to host CS75.net's mail here. Set me up. They then tell you, here is a list of MX records you need to create with your registrar. Maybe it's Bluehost or GoDaddy or whomever. You then log into your registrar, create those appropriate MX records, and some number of minutes or hours later, if someone in the world emails mailin@cs75.net or anyone else, it might, the initial contact might be made to your DNS servers, but then it's going to say the IP address of Google server, and so that email gets routed to Google, where a Gmail-like interface is waiting for you. You get a nice little branding logo if you want to upload your own company's logo or whatnot, and bam, email is outsourced. It's amazing. And frankly, for educational purposes, for small businesses, even for personal purposes, if you want to have your own domain name, I can't emphasize enough how nice it is that so many services are free to little people like us these days. And even in a corporate context, it tends to be a win. So if unfamiliar or if these are problems you have to deal with yourself, it's really a compelling option. And it relates very much technically to this kind of stuff. But once we've set up our mail, more on an ongoing basis, we might be developing different applications or different websites. We might want to have foo.lemonade.com, bar.lemonade.com. Well, how do you actually create these types of records? You have two options, A records and CNAME records. Canonical name is CNAME. Essentially, CNAME, and this is a little bit of a white lie, but CNAME is an alias where an A record is an authoritative record that literally maps domain name to IP address. A CNAME maps domain name to another domain name, or more technically, fully qualified domain name. So it's an alias in the sense that it's kind of a synonym for an address, but it introduces a layer of indirection. So what does this actually mean for me? So what I can do, if I own the domain cs75.net, if I have the domain cs75.net, first, I need to tell the world where this domain name lives if I actually want to have a website. Now, for the root level domain, cs75.net, no domain name, you actually have to make it an A record, not a CNAME. So this just means you have to tell the world what the IP address is of the server on which this site lives. And let's call it 2.3.4.5. And this, again, is an A record. But now suppose I want to have something like mail.cs75.net. And don't do this yourself because I'm making up the name as I go. But suppose I read in Google's instructions that if I actually want to be able to visit my Gmail-like interface that I've outsourced to Google at mail.cs75.net, odds are they're going to tell me to make a CNAME record that maps mail.cs75.net to not an IP address, because that would be slightly annoying because Google then's hands would be tied. If they ever change their IP addresses, what would happen to me? This mapping would break that I'm hinting I do, or I have to change it myself, which is just not good for people all around. Better if we decouple it. And so what they'll probably tell me to do is, again, here's the white lie, because I'm making this part as I go. Actually, this might actually be true. hs.google.com. This actually might be correct. Hostingservices.google.com. What this tells the registrar is this. Map mail.cs75.net to another fully qualified domain name, this time hs.google.com. Now here's the layer of indirection. If I tell that story from before and I try to visit mail.cs75.net, the DNS response I get back is not an IP address. It's in fact another fully qualified domain name, hs.google.com. So what does my laptop next have to do? Now look that up recursively, then I presumably get back 2.3.4.5. So the upside of CNAMEs or aliasing is at least immediately obvious in that now I can map a name to another name, and I myself, the middleman, I don't have to care about what the underlying IP address mapping is. Google is still free to change that as they want, and when it changes, my setup will change as well. Now this isn't used as an aside for outsourcing purposes only. Even we, for the courses domain and other things, other courses I teach, we use CNAMEs to map our own subdomains to other subdomains in our own domain, just so that we don't have duplicate IP addresses all the time. We just say all of these subdomains map to the same place, so that if we change one, the rest of them change. So same principle here. But the downside is what now of having this layer of indirection for my users? So it takes longer. So there is some amount of latency on the internet. When you make a request, even if it's a small request, you might have 20 milliseconds, 200 milliseconds, hopefully not much more than that, of a round-trip time to go from client to server and back. And then, damn, now I have to make another such request. I've just literally doubled the amount of time I need to spend asking for this question. Now, caching does help. At least I only have to do that once, so there are some ways of mitigating that. But again, it's ultimately a design decision. But it's hugely advantageous, and it's something we'll take advantage of in the course so that you don't necessarily have to map all of your domain names to an IP address that the course owns, but rather we'll tell you something like, in Project Zero, hs.google.com, so that we ourselves can still be autonomous, move things around without breaking your setup throughout the term. Yeah?
After the redirect happens, is the address in the user's browser going to change as well? Could that confuse people?
Good question. Short answer and good answer is no. So at the DNS level, all of this is transparent to the user. So even though it's mapped to this thing here, the user does not see this unless the web server says to redirect to a different name. And that, in fact, Google does do that. Generally, if you go to mail.cs75.net or something similar, you'll end up at, I think, www.google.com/mail/cs75.net. So if they choose to do that, but that's higher level, so to speak. It's at the application layer. Good question. Other questions? Anything at all? All right. So A records, then, to be clear, are simply authoritative records that map the host name, or rather the domain name, or the subdomain name to an actual IP address. So I thought I'd make a quick introduction. The gentleman who just walked in here is Dan Armendariz. He's the course's head teaching fellow, and we'll be working with folks either in sections or in a grading capacity or in office hours or online via email or in Google Group. Whole lot of stuff he'll be up to. You want to say hello?
Hi.
Into my mic?
Hi.
Okay. So Dan's one of the trio of teaching fellows that we have. You will also meet before long a gentleman by the name of Alex and also Sid. And again, more on that via email when we actually try to find an optimal day and or time for folks. So besides web hosting companies, what's an alternative? Well, the downside of web hosting companies is that you really are in a shared environment and you tend not to have that much control, that much access, because you're in a user level account. You don't have so-called root or administrative access. This is good for security for the people owning it, but the downside is you just have a lot less flexibility. If you want to install this additional package for PHP or MySQL or whatever, odds are your hands are tied unless they're nice enough to actually install things on demand for you or have some kind of package system. You might just be stuck with what the default settings are. Also, too, in a shared environment, if someone else's website is getting really popular and yours is just kind of muddling along, well, your users are going to experience a slowdown just because someone else on that same server is actually getting very popular. And a perfect segue to the gentleman who's still standing. This is Alex Chang, one of our other teaching fellows. Do you want to say hello into my mic as well? But facing that way.
Hi, my name is Alex Chang, and I'll be a TF for this course.
All right, excellent. So that's Alex, and you'll meet him personally as well before long. So when a shared web hosting environment isn't necessarily ideal, what are some alternatives? Well, the most extreme approach, but sometimes most appropriate, especially in a corporate context, might be to run your own server and just give that server an IP address, perhaps with the assistance of some local sysadmin or network admin, and then inform your registrar what the IP address is of that server, install Apache or similar yourself, and put your PHP code and HTML code on that server, and voila, you are now on the internet and you're running the server yourself. And hopefully the IP address is static, as they say. It doesn't change. Otherwise, if it's dynamic with DHCP, like on a home network, your website might be somewhat of a moving target, even though IPs tend not to change that often. But what's an alternative where you don't have to buy the server, maintain the server, know how to plug in the server, and you just want to outsource this part of the problem? Well, there also exists what are called VPSs, or virtual private servers. And this, too, kind of is what the name implies it is. So one of the nice outgrowths of this trend toward multi-core systems these days, by this I mean you buy a computer these days, odds are you have one CPU but 2 cores, maybe 4 cores, which for all intents and purposes is like having 2 CPUs in one or 4 CPUs in one. In other words, your computer can literally do 4 things or 2 things simultaneously. Whereas for years, with just a single processor, single core, we only have, as humans, the illusion of computers doing things simultaneously. They just do them so darn fast in series, and then again and again, that it looks like everything's running at once. Well, normal people like us, and even in a server context, don't necessarily need 4 cores. In super fancy servers, you can have quad processor, dual processor, each with 4 cores, now with 6 cores. So you can have 16, 24 cores in a single system, which is kind of like having 24 CPUs. And you can have a whole lot of RAM, all in the same footprint, using the same amount of power as a few years ago, perhaps, though sometimes more, depending on all the specs. And so what do you do with all of these cores? Well, the downside of the state-of-the-art these days in programming languages is we as humans are not very good at writing parallel software. It's at least not very easy right now to write software that takes really good advantage of all of these computational resources. We're pretty much really good at writing single-threaded applications, and there's a bit of a hurdle if you've ever done it, even today, to writing multi-threaded applications, and just debugging them is kind of a mind-bending experience sometimes, because literally stuff is happening simultaneously, but not necessarily it's not necessarily synchronized. So you get a bug sometimes, but not others. So one of the upsides, though, of having so much proliferation of computing power is that companies like DreamHost, even, companies like Linode here, which is one of the more popular cheap vendors out there, are buying decent commodity servers. And by decent, I mean lots of RAM, maybe lots of disk space, and lots of cores, but not necessarily top-of-the-line stuff, just lots of those things. They're installing free or commercial software called hypervisors that create the illusion of having multiple computers exist simultaneously on the same hardware. So if I have a computer with 1 CPU and 8 cores, I could install something like VMware, the appropriate version, or Parallels, or ESX, or KVM. There's a lot of options, free and commercial alike these days. I can install this software, then I can create what are called virtual machines, each of which is running its own copy of Linux, each of which is running a different copy of Linux, maybe Windows over here, maybe Solaris over here, each one of which, each VM, virtual machine, has 1 core dedicated to it. So now you've taken an 8-core machine and created the illusion of 8 1-core machines, and you've given them each 1/nth of the amount of RAM in the computer. Now, what's the upside of this, at least for the course's purposes? Well, it means if you really want to have a LAMP setup, Linux, Apache, PHP, or more specifically, you want to have full control. If you want to upgrade the OS, you can do it. If you want to change some configuration file, you can do it. If you want to upgrade Apache to the latest to fix some bug without waiting for the sysadmins of the shared company, you can do it. You can get a VPS whereby you get not only a username and password, you generally get the root username and password or some mechanism for accessing it, and that server is now yours. It might coexist on hardware with other people's VMs, and those companies too might oversell. They might sell 10 VMs when they only have 8 cores, which means hopefully not all 10 people are operating at full duty cycle or using all the computational resources at once. Otherwise, you will slow down. But if you get some kind of SLA, service level agreement, which says we will give you this much many resources, it's a really nice way of having the outsourcing features of a web host, but the control of being your own sysadmin, for better or for worse. So this is just an arbitrary screenshot of current deals from a popular option, linode.com. Just to give you a sense, actually it looks like there's the prices. So for $19.95 per month, a bit more than DreamHost was, we get, ironically, less of everything, but you get more control. And if we read the fine print, we may, I'm not sure, get better guarantees as to what kind of performance we're going to see. I mean, there too, how can they possibly, for $6.95, give us unlimited storage and unlimited bandwidth? This is like Verizon's unlimited 3G and whatnot, which is actually capped at some amount or whatever. So you got to read the fine print with these things. Now, for many people, it doesn't so much matter, but depending on your application, even we suffered through these kinds of issues a few years ago when we started videotaping things and distributing things as QuickTime movies and MP3s. A typical lecture, when it's stored as a video, especially now that we shoot partly in HD, 200 megs per lecture, sometimes 500 megabytes per lecture. So you start to have a few lectures on a disk. Now you're up to several gigabytes. You make backups of that stuff. That's a lot. And worst is that the users actually have to download those bits. And so if every student downloads those files once, now you're talking about gigabits of traffic or terabytes of traffic being downloaded over time, depending on how big the class and the open courseware audience is. And so this starts to hurt. And so you start to pay attention to things like bandwidth allocation and storage space, depending on what data you're actually storing. So if you have large files even being downloaded by few people, you've got to be aware that you don't go over things like the bandwidth limitation. So at some point, things like DreamHost, at some point you realize it's too good to be true. I don't know where that breaking point is. Yeah?
You say that your website might experience latency, like how slow are you talking about anyway?
How slow?
Because I get very impatient, but it's not really slow. You know what I'm saying?
So it depends, and that's actually a good segue to one tool that we'll demonstrate early and then use throughout the semester. Generally, humans notice a response time that's larger than 200 milliseconds, or 1/5 of a second, and at that point they realize that this page is reloading. There's a flicker or whatnot. So actually one of the tools we'll look at quite a bit is this thing called Firebug. And so this is kind of an indirect way of answering, but the short answer is that it depends. What is actually slow? It can be seconds. I mean, I had a project running on a VPS by a different company that I am sure, they insist that this is not the case, but I am sure they are overselling the capacity on this server, because once in a while I'll be using something simple like a text editor and I'll save my file. 5 seconds later, will it actually save my 2 kilobyte text file? And that means that someone else must be really writing to or reading from that disk, and I'm getting blocked while their I/O activity is going on. So it depends. In that case, it's an infuriating 5 seconds, which for an interactive application is kind of a deal breaker, and I moved off of that server altogether. In the web context, it might be a few tens of milliseconds, hundreds of milliseconds. It really depends what the bottleneck is, bandwidth or disk or CPU, so totally depends. But I would say once it's taking more than a few hundred milliseconds, your users are going to start to notice, and you yourself might start to notice. So a really nice tool is this. I'm going to pull up, let's say, google.com. And in the bottom window here, I have this little panel. So the course itself is pretty agnostic when it comes to what browsers you use. Certainly, we don't care at the end of the day, but we will strongly preach the virtues of using Firefox for development purposes because there's such a rich availability of free plugins that make development really nice. Now, in fairness, Chrome and Firefox and even IE do have very similar functionality built in, maybe not as rich a community around it. Personally, I've always liked Firebug, and it really works well, whereas I've personally never really liked what comes in WebKit, aka Safari and Chrome these days. But really, to each his own. But we'll generally demonstrate at least one of these tools so you can see how you can start poking your taking a look underneath the hood at your own projects and code so that you can get a sense of where the breaking points are. You can debug it this way, and we'll come full circle back to HTTP in a moment and actually look at that HTTP traffic we described only verbally before. So notice there is a net tab here in addition to DOM, script, CSS, and HTML. I'm going to go ahead and I'm going to type the full address just so we know exactly where we're going. Enter. Damn it. And because I've not used Firebug there, it closes by default. So let's do this again. I'm going to reload the page. And at the bottom, what I see here is that loading google.com actually involves a total of 11 HTTP requests. Now, what might those requests be? I just visited one web page. Well, odds are you already know that you download a web page. Odds are it's got like maybe some CSS files, JavaScript files, maybe an image or more, maybe like Flash or movies or whatever. It's probably not a single HTML file in this day and age. So what are these files? Well, we can actually look at them. The first one here was for this original request, google.com. And notice this is pretty good, 143 milliseconds, and the response came back. Where this server isn't obvious at first glance. Maybe it's in California. Maybe it's hopefully more local to us here. But let's dive in. So I click this now, and we see these so-called headers. So HTTP does send a message like this. That was not a lie. But it was kind of a lie when I implied this is all it sends. There's actually a lot more going on underneath the hood. Some interesting, some useful, some not so much. This is all of it for this particular transaction. So you see here, under request headers here, if I click view source, and I'll zoom in, it'll chop off the end here. But notice that when I clicked view source, this is literally the message that my browser sent, unbeknownst to me, the human, when I hit enter. So it first says get/HTTP 1.1, so I was telling the truth there. But it also sends host:/www.google.com. More on that in a moment. It also sends user agent. What's user agent? So that's the browser. So as an aside, if you've never realized, not only does every website you visit know your IP address, for better or for worse, they also know with high probability what browser you're using and what version you're using. And the curious thing, too, as an aside, from a privacy perspective, turns out that by knowing what browser you're using and by checking a number of other details, generally via JavaScript, you can pretty uniquely identify users by the specific set of plugins and configuration that they have. And also, as a scary aside, probably more on this in our security lecture, you can even figure out, as a server, what websites people have visited by a known flaw in CSS, whereby you can essentially ask the browser, here's a list of websites. Has the user been to them? So you can't find out a list of websites the user's been to, but you can say, here's a list, which of these have they been to? Essentially exploits the age-old notion of being able to click on a link and it changes color, back in the day from blue to purple. Well, that's a CSS property, and if you essentially detect underneath the hood a whole lot of purple links to like sketchy.com, well, it turns out that if sketchy.com is known to be purple in the browser's memory, the user has been there. So some really interesting stuff goes on underneath the hood, and we'll talk to you about that throughout the term. So cookies are not the only threat. There are other things as well. And cookies, actually, let me retract. Cookies are good. We're going to use them a whole lot, but they can be used for evil purposes. So, and then all this other stuff, which is fairly esoteric, talking about what encoding the website accepts, does it do compression, what language, and all of this. The really juicy stuff for our purposes are generally going to rest in the lines like the host line up top, the cookie line down here, and sometimes this caching stuff. But more on that when we look at PHP. So why this host line? Why am I telling Google.com that it is Google.com? Feel like they should know that. Yeah?
Well, I mean, you could have aliased to the same IP address.
Okay, excellent. So even though Google is probably an exception here, whereby they have so many servers and most of their applications, even though they come under different names, tend to still live under www.google.com these days, for smaller websites that use web hosting companies, or even that use web hosting companies, you might have 2, 3, 10, 20 websites, 20 different fully qualified domain names, all mapping to the same IP address. This is actually a good thing because even though there are 4 billion IP addresses in the world, there are only 4 billion, and they're getting swallowed up increasingly fast. So it's a useful thing if I myself can map multiple websites to my one IP address. I don't know if you glimpsed, but at the price sheet on DreamHost, you actually have to pay like $3 extra if you want a dedicated IP address because they're a relatively scarce resource. But if you can have multiple websites living on the same server, and when we tell this story, the web server lives at, say, one IP address, and yet how is he supposed to figure out, do I return Yahoo.com's news or MSN's news or Google's news or whoever? If you have all these different websites, arbitrary example, living on the same server, how do you multiplex, so to speak, among them all? Well, thankfully, thanks to HTTP 1.1, a special header is supposed to be sent from the browser that's a reminder to the server what the user actually typed into the address bar, what was actually requested, so that the server, in addition to realizing, oh, this is a request packet for me because it came in on my IP address, on my Ethernet card, it can also do some introspection into the packet, into that envelope, and say, oh, this user wants a website on my IP for that host name. Let me go to the specific folder on the server that www.google.com's content lives in and return that index.html or equivalent and not someone else's. So for the course, this is pretty much the same idea. All 50 or 100 students in this course, local and distant alike, are going to map your domain name or some subdomain ultimately to the same IP address. But thanks to HTTP 1.1 and thanks to browsers obeying this convention, anytime you or a friend visits your website, it's going to end up at our website, but our web server software, Apache in this case, is going to look at that header and send it to your user account, or your user account, or your user account. And this is a wonderful thing, but has some interest. There's always a catch. Kind of breaks down with something called SSL and secure websites. Generally speaking, you need a unique IP address to run a website on SSL, though there are some exceptions to that. And that's kind of a problem, and that's where the companies stick you with the $3 extra surcharge if you want SSL. We'll come back to this, but essentially it's a chicken and the egg problem. SSL is all about encrypting information. HTTPS is SSL. Problem is, if you encrypt this information, the header, the host line, is encrypted, so you can't decrypt it unless you know what website it's destined for, but you don't know what website it's destined for until you've decrypted it. So you kind of have this this problem, catch-22. And so it's kind of an unfortunate design decision that the host line also gets encrypted in this whole process. But that's the way the protocols work. What does the server reply with? Well, we said before it replies with the home page, the day's news or whatever, but it also replies with some headers. So here are the response headers from google.com. Notice it says 200 OK. This is the best error code, so to speak, that you can get from a web server, and you never see it. You see 401, you see 404, you see 500. These are all generally bad error messages or status codes. 200 is the best of them because it means nothing went wrong, and we never see it because it's behind the scenes here, but there it is. The server is saying you request a file that does exist, you can read it, I can send it, good to go. Here are the bits for it. But it also tells you things like the date and time this thing was modified for caching purposes, potentially, what the name of the server is, if that's relevant, what type of content it is, so that the browser knows to show it, to open it, to play it, to download it, whatever the so-called MIME type is carried in that header there. So this is Firebug. It's a wonderfully useful and free tool. It's linked under the software page of our website. But just to show you some other details, if I click the HTML tab, for learning and development purposes, it's also wonderfully useful. Google.com is not a very useful learning tool when you pull it up and you try to sift through this mess. And this is actually pretty short, right? They are being very, very space efficient with their bytes. There really is not much white space going on in this file, in Google's case, because they pay for every byte. Smaller websites, perhaps less of a concern. But my God, like, how am I supposed to learn from this? Or frankly, if it's my code, and I just happen to write code like this, how do I actually make my way through it? Or if I'm looking at a website I really like, genuinely, some technique they've used, how do they do those drop shadows? How did they align that text in that way? I genuinely want to learn from their design, but not have to try to sift through that code. One of the things that Firebug and WebKit and IE's tools do is they clean up the code for you as best they can. So what I'm doing now, and I'll zoom in, is I'm looking at the so-called DOM, document object model, the tree structure that represents this document hierarchically in a pretty printed fashion. And these little arrows allow me to dive in deeper and deeper. And this is wonderfully useful if you're trying to, again, debug your own code. You can look at your HTML forms. You can look at the ID attributes you've given things. You can, on the fly, watch this. Let's see if I can pick a good example. There's not much text we can manipulate on google.com, but let's do this. I'm going to right-click on Google Search, and this is another entry point. Also, you can right-click or control-click on something, choose Inspect Element, and in Firefox, once you've installed this plugin, it will open Firebug and jump to that point in the DOM. And just to be clear, this DOM tab does something different than the HTML tab, but same idea. So notice I've drilled in deep here. What's really cool, and this is hinting at useful purposes. This is not something that you'll find useful all the time, but it's just kind of neat. I'm going to say David's search. I've just changed google.com. I think it's impressive. So why is this useful? For programming purposes, not so much. But for those of you who are interested in design and like to tweak things and kind of obsess over CSS-like details, being able to change your CSS on the fly and even the content on the page on the fly like this, turn rules on and off and delete content, add content, honestly, it so expedites the process whereby otherwise you'd have to change your file, reload the whole page, look at it again. I mean, this really does expedite things. You can do it all client-side. And also, with regard to CSS, even though this won't be a focus of the course, if I look at any element, for instance, if I look at, let's say, these links up here in top left, Inspect Element, notice I can highlight any one of these elements, and I can see what the corresponding DOM element, the div, the span, the whatever, that corresponds to that part in the page. So it allows me to home in on specific parts of the page. If I then choose this thing here, and then I look over here on the right, it shows me all of the CSS rules that at this point in the document actually apply, and consistent with the idea of cascading style sheets, it shows you from top to bottom which ones are preempting earlier ones. So honestly, it makes so much more about web development just easier, and you can find stuff, especially in large CSS files, so much easier. And then in all of these tools, again, this is not limited to Firebug and Firefox, you can highlight these things, and let's see if we can pick one good example. Turning off that background is not useful. How about this? OK, so minor tweak. But notice I've clicked the little Ghostbuster symbol, and I've turned off that rule, and I immediately see the effect. So again, not going to be a focus of the course, but it does hint at what you can do in the way of introspection of an HTML document, and we will use this quite a bit, or we'll recommend using this quite a bit when we start inserting forms into our own sites and inserting names and values, and we want to actually see what's going on there and then watch the traffic. And then it also includes a debugger for JavaScript so that you can set breakpoints even. You can walk through your JavaScript code. It's a wonderfully useful development tool that at the end of the day, spend an hour learning it, save many hours long term. Yeah?
Is there any way to export the changes that you make in Firebug to your document so that it doesn't get erased when you close the browser?
You know, that's a good question. I suspect as much. So if I click Edit, what I then get is the raw source, not pretty printed in that fashion. So I'm guessing I can copy paste in that way. I've not had to do that myself, but I'm guessing if you poked around, there might be something like that. It's a good question. But I'm not sure. So I would use that as your excuse for your 1 hour learning curve. Other questions? All right. So where does that leave us? So we've told the story involving other people's servers and how you get access to them. But how do you actually then connect to them once you have a username and password? Well, many of you are probably familiar with a command line in DOS, in, say, a Windows environment, or in a Linux or Unix or Solaris or whatever environment. And this is one mode of access that you will have to the course's web servers. Again, moving forward with the projects, we'll make quite clear how you start doing this. So realize today is not the only tutorial, but among the ways you'll be able to interact with the cloud account that you'll be given is via SSH. This is a screenshot of Terminal, which is a free program that comes with Mac OS. A free equivalent in the Windows world is called Putty, P-U-T-T-Y. It's highly recommended, if only because it's free and sort of omnipresent out there these days. Harvard's campus, for some reason, still pays for a site license for Secure CRT, which some of you might have used in other courses. It, too, is fine, but you pay for it, and it really does the same thing that Putty actually does. So realize that, and actually this is a good message to send now, for the course, you will not need to buy any software, and for the most part, think entirely do we use free and open source software entirely. Not even so much philosophically, but just because there is so much good software out there, you certainly don't. One of the messages of the course will be you really don't need in the world of web development to pay for operating system licenses or for web server licenses. And I mean, this is kind of an indirect, admittedly, on Microsoft and sort of their products, but certainly for web applications. I'm always kind of fascinated when I visit a site and I see that the URL ends in .aspx or something similar, because it means they're paying for Windows, they're paying for the server software that they're running on that computer, and I always wonder to myself, and maybe they have reasons, but why? And one of the takeaways we'll have in the course is even though we happen to use PHP, there are even many free alternatives to what we're using in the way of web servers and languages. So do realize that what's really cool about this stuff these days is everything we do in class and do this semester, you can also do at home, ultimately for free. SFTP stands for Secure File Transfer Protocol, and this exists in multiple forms. This is a commercial program Harvard has called SecureFX, but there's plenty of free or shareware versions for Macs and PCs alike. WinSCP on Windows, Fugu, F-U-G-U on Mac OS, and CyberDuck on Mac OS. But again, all these kinds of things will link on the website. No need to always write things down. And it's just a means by which you'll transfer content from your computer to the cloud. So then a quick word on web pages. So per the syllabus and the course catalog, we do assume that students in the course have familiarity with HTML and have prior programming experience. So we addressed before break the idea of prior programming experience. So a quick word on HTML. It's really the programming prereq that's the more useful of the two. If you've never written HTML, it's really not that hard. And one of the goals of Project Zero is going to be to make that clear to you, that certainly to the extent we need it in the course for implementing user controls and forms via which we can get input from users, you can learn what you need to know for HTML, certainly for the course, in like a night, and you get better at it over time. So it's not something we'll spend much time on, but you can look on the course's resources page, and perhaps as unofficial homework before 2 weeks from now, for those unfamiliar, can teach yourself a little bit about HTML. And what's nice about HTML, I will make a very simple web page right now. I'm going to use a free program called TextEdit. Equivalent is Notepad on Windows. I'm going to cut some corners. This isn't going to be wholly valid, but just to convey the message, here's HTML, and here's head, and here's hello. Oh, actually, I'm doing the homework that I promised we'd do, but that's okay. I'll make it more interesting. Body, and hot, hello world. This is boring for most people here, I bet. Oh, there's a bug. Someone should have caught this. I'll fix. All right. There. But this is really just to send a quick message that if you don't know this stuff, really not a big deal. Can learn this stuff particularly fast. Hello.html. Save. Yes, don't let it change my extension. Now, I'm going to click this file, drag it, voila, there's my first web page. So that's HTML. Now, there's some more nuances to it, and certainly if you want to start building compelling websites, it will take some time to learn, but this is only to say that if this is what you're a little nervous about, not a big deal whatsoever. But a couple of things we will point out in terms of structure and in terms of the first of several libraries we'll talk about in the course. So this is a canonical web page written in a language called XHTML 1.0. We'll also allow and encourage experimentation with HTML5, whose syntax is slightly simpler in a lot of contexts, which is nice. That mess of text at the very top called a document type definition, which we'll talk about in our XML lecture, doesn't need to be there in HTML5, which is nice, because to this day I can never remember to type that. I always copy-paste it for several years now. Things are a little simpler, but the things we draw your attention to here is, for those unfamiliar, CSS is about kind of taking the aesthetics of your page, the final mile, and decoupling aesthetics, stylization, colors, font sizes, and all of this from your actual HTML markup, which is a good principle in general. We'll talk about this in the context of PHP too. Here is an inline cascading style sheet. Style tag, open and close, inside of which is some number of style sheet properties. In this case, you can kind of infer what this is doing. This is going to make the body element of my web page, who happens to be there, have a background color of white. And if you've never seen hex numbers before, also totally easy. So an external style sheet, and this again is to hint at the conversations we'll have about scalability. You can also say, I have some CSS properties, some rules, but they don't live in this document. They instead live in this file, and here's where they live, via this tag. Just at first glance, why is this useful to factor out your CSS? Yeah. So caching purposes. What's nice here is that if you have a whole bunch of rules, not just a single one-liner that I had for playful purposes there, you've got like 20 or maybe 100 or so lines of CSS that stylize your page, and all of your pages, all 10, 20, 30 of your pages on your website use those same rules. If you include them in the HTML source code, that's several bytes, several kilobytes that your user is downloading again and again. It's just a waste. So caching is allowed to happen here because the browsers don't have to request that again and again. A downside, again, the theme of the course will be nothing. You get nothing for free. Other than the software, you get nothing for free. What's the downside of this? What's it? What's that? So there is. For the first page load, there's extra time involved because of that same latency. We saw for Google.com alone, that's 11 requests. Now, that's not horrible, but each of those has some amount of latency, and some of those requests can't start until the others return, because not until you download the index.html file or equivalent do you even know what other files are needed in order to render that page. To put this into perspective, too, Google are definitely among the savvier, more cost-conscious folks out there. If we pull up a similar site, let me pull up CNN.com and then pull up Firebug. Let's see if they've cleaned this up since the last time I played this game. So CNN.com. 137 HTTP requests to pull up this web page. This is why this website is slow when you are on a slow connection. This is part of the reason why this thing is slow when you're on a mobile device and it's not a mobile-specific document. And this is why you can see the time frame there. This moving timeline shows you 40 milliseconds there, 8 milliseconds there. So little things, not terribly much, but my God, it adds up. And 137 requests. Now, where are a lot of these requests coming from? Where are the responses coming from, rather? It looks like, so definitely some images. Turns out there's a lot of Facebook in here. So CNN kind of partnered up with Facebook for their comments. So some of the content's coming from Facebook. Some of it's coming from Turner.com or their content distribution network, CDN. So a lot of this is images. A lot of this is CSS. Frankly, a lot of this is probably also ads. If we scroll back up in the history, where Google is much more minimalist. So it's not quite a fair comparison, right? Google's kind of known for its minimalism. But when it comes to scalability and performance, that's kind of a lot, frankly. No matter which way you cut it, hopefully there's a better way. And even here, do you have design decisions to make? So you'll see increasingly over time that there's a lot of libraries you can use. We'll talk about some of them in the course: YUI, jQuery, MooTools, XJS, whole bunch of popular ones. And each of them comes with their own CSS files and their own JavaScript files. And you yourself, practicing what you were kind of taught in Programming 101, you do good design, you put this set of rules in this file, you put this set of rules in this file, these functions in this file. And so you have maybe 5, 6 files. But if you include each of those in the head of your web page, just like we did for CSS, you're going to now incur an additional HTTP request for each of those files. Now, some browsers are smart, and even though I said they'll typically disconnect after requesting the page, thankfully these days they'll keep the connection open, the TCP connection, the underlying TCP connection open, and go fetch more files on the same tunnel, so to speak, but there's still the round-trip times back and forth. So one of the things Google has done here is they haven't really done this most likely to obfuscate their code so that no one can steal their very minimalist website. Rather, they've done this for 2 reasons. They've minified their code, as they say, so that, one, they're not sending any gratuitous bytes across the wire, because bytes is money and bytes are time involved for the user. Any additional bytes takes slightly more time, even if minuscule, but it adds up. So they've minified even their home pages of code, which is not terribly common because it's kind of a pain to do it well. But if you look also at any CSS files that a typical website has or JavaScript files, you can do any number of things. And we'll talk about these in the course. You can minify it, run it through a special program that essentially throws away all of that useless white space. Useless for the computer, good for the human. Any variables that you've been taught to call something like total quantity or discounted price, a variable that says what it is as opposed to XYZ, computer doesn't care, so these programs will sometimes take your long-winded variables and change them all to x's and y's and z's because the computer doesn't care, but that saves bytes. And it also has the side effect of obfuscating your code because, as we'll discuss mid-semester, with anything client-side, you're kind of stuck with shipping the code to the client, which means they can see it, the human, and you can do your best to encrypt it and obfuscate it, but there is no such thing as encryption when it comes to encrypting client-side code because it's got to be decrypted to actually run it on the computer, so it's kind of this farce. Anytime someone said, go ahead and encrypt your JavaScript, you have to include the encryption key with the encrypted JavaScript, which means anyone with a modicum of technical savvy or Google abilities can figure out how to decrypt your code. But this is one of the interesting design and intellectual property issues we'll discuss over time. We mentioned this site, which will be a huge boon for just doing sanity checks on your own code. But one of the themes, too, will be cross-browser issues, at least to some extent. This is one of those unfortunate things, if you've not really dived headfirst into web design yet, where even though it's 2010, none of Google and Mozilla and Microsoft and Apple actually agree on things still when it comes to certain standards and interpretations of specs. So this is the sort of thing where for a typical project, if you really want to make your site work identically across all the major browsers, you will spend 20% of your time implementing your project or your application or tool. Works great, except, and it's eliminating that preposition at the end that takes you 80% of the time. It's a complete nightmare. Thankfully, lots of libraries, some of which we'll discuss in the course, help take these headaches away. A lot of the libraries we'll discuss are designed by people who put in that investment of time, figure out all the nuances of getting something to look or behave the same across all the major browsers, so you can just use a little widget, an off-the-shelf library, and not have to fight that same battle. For the course, this would take the fun completely out of most of the projects, but we do think it's important to experience the nuances of cross-browser development because it is not acceptable, I think, philosophically and just in real-world terms these days, to put a little footer that says must use IE or must use Firefox or looks best in Safari. Inexcusable these days. It might be a pain in the neck to actually make these things work, but there is no reason you have to mandate browsers anymore. You can absolutely, and as developers, and certainly educated developers, there are ways to surmount this. And so what you'll see in the specs for projects 1, 2, and 3, that you do have to get your project working in at least 2 major browsers. And it's up to you to choose which ones, but we will essentially compare them side by side, functionally, aesthetically, and it's a good way of doing a slight bang against the wall, but not 80% of the time, which would really defeat the pedagogical point of that exercise. So a couple of teasers for libraries we do like to use a lot that you might want to keep in mind for Project Zero. But again, more on this in 2 weeks' time. So YUI is one of the most popular set of libraries for JavaScript and for CSS. These two here are really nice because one of the first things you notice when you start making a website, even with just HTML and graphics and CSS, is that you pull it up in Firefox, you pull it up in IE, they look different. Like you'll see 10 more pixels around this element up here. The size font is different for some reason, even though I use the same number. So among the things some of these libraries do, and I've gotten into the habit of using this as a starting point for any project I do these days, the folks at Yahoo have figured out all of the silly little CSS rules that make all HTML elements behave the same out of the gate on the major browsers, aesthetically. Not programmatically, but aesthetically. So you include, if you go to either of these URLs or just Google YUI fonts, YUI reset, you'll see that you just include a script tag, or a link tag for the CSS that gets you started here. And it's not necessarily a requirement for all the projects, but it's just a useful, wonderfully useful design technique. You use it essentially as follows here. But lastly, this. So turns out that even if you don't know some HTML, you read some of the recommended resources or one of the books in the next couple of weeks' time and bring yourself up to speed on the basics, but you'll get plenty of time to play with the first project. Really, all of the dynamism that we'll be implementing in the course, it's amazing, but boils down to very few input mechanisms. The browser world has not given us all that many tools to play with, but the world has really used these 6 or 7 basic UI input mechanisms to a great extent. And thanks to JavaScript and CSS, can you kind of roll your own? And that's what you get in the form of widgets from YUI and jQuery and MooTools and all of these special libraries we'll talk about. But at the end of the day, we'll be starting our conversation in 2 weeks' time on basic form elements, and not just how to make them, because frankly, here's how you make them in a web page, but how you then handle the data that's being submitted from client to server and that's where we'll pick up our conversation on PHP and implementing the first of our dynamic websites. So more on that in 2 weeks' time. No official homework until then, but keep an eye out for the emails from me about the Google group and also about some sectioning logistics. The TFs and I will stick around for a while for Q&A, but otherwise, we will see you in 2 weeks.